start by advancing my slides too quickly. All right, welcome to Pump Up Your Cloud Infrastructure with Azure Bicep. My name is Dustin. I am a principal consultant at RSI. Recently a principal consultant because we just got acquired, so it's been an adventure. If you want to look at any of this, if you want to look at any of my stuff, I got website, LinkedIn on the slide. Also, if you want to check out any of the demos today, those are available for you at the GitHub link there. You can go there and you're good to go. So let's talk about our path to gains today, knowledge gains. So we're going to break this talk up into a couple of different parts. First, we're going to start talking about infrastructure as code. Bicep is an infrastructure as code technology, so we want to kind of establish some context as to where that fits into the flow. Then we're going to talk about the Bicep language and kind of go through a quick list of its different features and how to make Bicep files and run them. We're going to cap it off with some pro tips. So these are things I learned working on an Azure Bicep project. So these are from experience, also from working with ARM and other similar related technologies. So these are just some shortcuts to make your life a little easier. And then we'll finish it off with a demo where we walk from Azure pipelines all the way back down to the Bicep templates to show you an example of infrastructure and how it all kind of fits together. So with that, let's move on to infrastructure as code. So, obviously infrastructure as code is good, but why is it good? Why is this an important thing to learn? Why is it an important thing to, implement in your organization? The first reason is speed. In the bad old days, if you want infrastructure, it's going to take you a hot minute. And by hot minute, I mean about 6 weeks. And that's if you're lucky. So you put in your tickets, you kick it over to infrastructure. They get mad because you want your infrastructure within, months, as opposed to like having a pizza party and a project and, waiting weeks and weeks to get your stuff. And then when you get your stuff, not necessarily exactly what you want. And that's not ideal. But if you can write out your infrastructure as code, that 6 weeks takes you about 5 minutes. I mean, obviously, if you have to write the code, that's going to take you maybe a couple of days. But at the end of the day, it's going to take you a lot less time to code up your infrastructure and run it in a pipeline and get your stuff set up than it is to have some team that's probably overworked, that probably has 15 other teams trying to get their attention, have to press a bunch of buttons for you, and it's going to have a huge lead time. So speed is probably the biggest advantage. The second advantage is consistency. One of the problems you have is when your infrastructure takes 4 weeks or 4 to 6 weeks at a minimum, and you have these long-running servers, the configuration on those servers tends to drift apart over time. This creates situations where something works great in QA, but when you promote it to prod, it doesn't work anymore. And it doesn't work because your environments aren't the same. They aren't consistent. And so the nice thing about code is that you're running the same code for each one of your environments. Therefore, your environments will be consistent. They will be the same. And additionally, you won't be fiddling with them manually, because if you want to change something, you will change the code and implement it in all of your environments. So you don't have any of that nasty infrastructure drift like you do in a manual configuration situation. Thirdly, repeatability. Similar to consistency, repeatability is really nice because sometimes you just need an environment quickly to do something, similar to what you have in production. So like, for example, load testing. Load testing is something you want to do. Probably not a good idea to do it in your production environment, because it's going to degrade service. You don't necessarily want to do it in your QA setup because, well, people are using it to QA, so nuking your QA setup is going to cause a productivity loss. But in addition to that, it's also probably going to be underpowered versus your production environment. The beautiful thing about infrastructure as code is with repeatability, you can basically mirror your production environment, throw whatever load testing you want, and then nuke it when you're done. So not only do you get repeatability, you also get the ability to create temporary environments at will to do cool things like testing for load, testing for security, and these other kind of destructive tests, so you don't have to ruin your flow or inconvenience your customers. And finally, ease of editing. Because guess what? While the infrastructure people aren't perfect, guess what? Neither are we. So when you make a mistake, you can edit your code, you can run it through a pipeline, and bam, you got infrastructure. And you can fix your problems very quickly if you can iterate, as opposed to trying to go click the button somewhere to figure out which setting you messed up. And then you have to figure out how to do that in all of your different environments. And remember to do that the next time you set up a new environment, which is not ideal. So ease of editing really makes your life a lot easier. So infrastructure as code is important and comes in two flavors. The first infrastructure as code flavor that you're going to encounter is the procedural flavor. This is where you just tell the computer what to do. So if you've ever used Chef, that's an example of a procedural infrastructure as code technology. One that you're going to see a lot of is Azure CLI or the Azure APIs, regardless of what language they are, all fall in this category of procedural infrastructure as code. And while this is a perfectly valid way to define your infrastructure and build it, my personal preference is declarative methods. So instead of telling the computer what you want and having it build each individual piece of infrastructure, it is instead what you're going to do is you basically say, I want my infrastructure to look like this. You go figure out how to do it. And what's nice about this methodology is that if you have, the state of your current infrastructure is taken into account and you don't have to write a bunch of code to say, oh, well, if I already have these, one of these don't make it. Or, if you have to do a bunch of protective stuff. Instead, you can just say, I want this to look like this. And the other nice thing about declarative methodology, especially in things like Kubernetes, is that if your state changes, especially if you're using Kubernetes, it will change it back for you. So for example, if you're running a bunch of pods and you say you nuke a pod for whatever reason, Kubernetes will bring it back. But that's specific to that. So there's a couple of different ones. Kubernetes manifests are an example of declarative infrastructure as code, additionally Terraform and ARM templates. And ARM templates are where we're going to begin in our sort of Azure infrastructure as code journey. So ARM, how many people here have used ARM templates? So interactive.
I have.
Okay, so we have a couple people. So for the people who haven't used ARM templates, ARM stands for Azure Resource Manager, and it's an infrastructure as code format. It's based on JSON. And essentially what you do is you have these template files where you define the different resources that you're going to build. And you have a template file where you define your resources. Then you also have a parameter file where you define all the different variables in your environment. So, that is, the essential definition of ARM. You deploy those bad boys with the CLI. So you just do an AZ group create, and then you can do a deployment group create. And there's a similar one if you're doing Azure PowerShell, where you can do a deployment group and create it using an ARM template. And ARM is cool. ARM is really nice. It's a good declarative format, but there's a couple of downsides with ARM. The first downside is that it's Azure only. So if you're using Azure, which most people who are using a cloud provider are generally using one for most of their stuff. I know there's some companies that are trying to do multi-cloud, but most of the people that I've encountered tend to stick with one cloud provider for most of their infrastructure. So Azure only, though that's not such a bad thing. If you need something that is not Azure only, Bicep and ARM are probably not going to be for you. You probably want to look into something more like Terraform. The second disadvantage of ARM is that it is verbose. It is a verbose JSON format. There's just a lot of stuff, a lot of cruft, a lot of just junk. It's a lot of code. And the final thing is it's hard to get started. The biggest problem for me is that there really just wasn't a lot of good explanations of how to write ARM templates, and you just kind of have to figure it out over time. And it gets easier. Like ARM templates become easier to understand, but that initial oh, here you go, figure it out is not so good. I don't know, maybe other people are smarter than me, but I definitely felt like there was a little bit of a learning curve with ARM templates. And obviously the first one, Bicep's not going to solve that problem, but the second two, Bicep does stuff, and that's really where we're going to enter with Azure Bicep. So Azure Bicep was created by Microsoft to solve the verbosity and difficulty problems with ARM templates. So basically, you can think of Bicep as it's basically TypeScript for ARM templates. And it's defined as DSL for Azure. It supports 100% of the Azure APIs day one. So unlike Terraform, you're always going to get 100% of your stuff supported in Bicep. It compiles down to ARM templates. So, again, it's sort of a TypeScript to ARM templates. And you can compile them down to ARM. You can actually compile ARM into Bicep, though it doesn't work super well. It's much easier to read than ARM templates. So it's just basically it's a nicer way to make ARM templates. And if you want to use Azure Bicep, the first thing you need to do is you need to get the Azure CLI, so basic deal there, and then get yourself the Azure Bicep Azure CLI package. So it's a AZ Bicep install, and that will get you all the Azure Bicep commands that you can use. Bicep templates look like this. So here's a basic Azure Bicep template. You have a parameter. So in ARM land, you have to declare those at the top in a single section in your documents. In Bicep, you can kind of declare them in different places, wherever that's convenient. Same goes with variables. You don't have to declare them all in the same place. You can add attributes to your parameters and your variables, or you can add attributes. So in this case, we have a min and max length for our template variable. And then to create a resource, you just use the resource keyword. You give it a name. In this case, we have a storage account. You throw in the Azure resource type, so .storage accounts, and then you drop in your details. So this is your basically your different variables. And the thing is, all of the information here, like name, location, SKU, all that stuff is exactly the same information that you're going to put into your ARM template. So if you have an ARM template that you want to turn into a Bicep template, you can go one-to-one on all these different data points. They're the same thing. To deploy your Azure Bicep templates, you basically do the same thing you do with the ARM ones. You create your resource group, you do a deployment group create, and you toss in your Bicep file. You can compile it down to ARM if you like, or you can just directly throw the Bicep template up into the cloud, and it will compile it for you. Or it'll transpile it for you. So you don't actually have to compile it down. Parameters, you can have, you can define a data type. You can add default values to your parameters if you want to make them non-required. You can have different attributes. One handy one is allowed. So you can put in your allowed values so you can restrict what people enter. That way, if you have like specific environment codes or SKUs or different kind of enum type deals, you can restrict those values to make people's lives a little easier when they're consuming your templates. Additionally, you can also use string interpolation in your parameters templates. So you got a lot of options. Variables are kind of the same deal. One nice thing about Bicep variables, you can put them anywhere you want. You can put them, anywhere you want, like right before you're going to use them, so you can have a better flow. Similarly, you don't really need to declare the type on them because you have a value for that, and it does it infers the type based on what you put in. Again, you have that nice string interpolation, just like everything else, so you don't have to do a concat or anything like that. You just string interpolation, and then you just use your variables like you'd expect. Dependencies, another thing about ARM templates and Bicep templates is that when you run them, they'll try to run the resources in parallel. So they'll try to run everything at once. This is fine some of the time, but if you have different things that rely on other resources, you want to make sure you add a depends on to establish those dependency chains. So for example, here we have a website. The website, that Azure website depends on an app services plan. So you want to make sure that app services plan exists before you run that. Otherwise, you can get into a situation where you run your template and it'll throw an error at you because the resource that it's creating isn't there yet. Additionally, you have a long list of functions. These are the same functions you have available in your ARM templates. You can also use them in your Bicep templates as well. A couple of useful ones, you have a unique string, which hashes a value. You have 2 lower, 2 upper, which is handy if you want to mutate names. Resource ID, if you have an existing resource that you need to get the ID of. and of course contains a lot of other logical variables. There's like 36 or so built-in functions. So these are just a few of the ones that I found useful. Another really useful feature of Bicep is modules. So modules allow you to break down your Bicep files into smaller chunks so they're easier to read. And to create a module, you basically just make a Bicep template. So this is a module that creates an application insights space. And we'll check out the full file later. And in order to use those modules, use the module keyword, and then you can point at your Bicep file and then drop in the necessary parameters. That will give you output, and then that output can be used in other places. Does that make sense? I'll assume silence makes sense. If anybody has any questions, you can go ahead and throw them. You can throw them in the chat. So, and we'll go through the actual templates for the example in a little bit more depth in a minute. So, a couple pro tips. The most important thing to do when learning ARM or Bicep is to cheat. And the first way you can cheat is you can go to the Azure Quick Start templates. So the thing is, regardless of what you want to make, I would say that there is a very high likelihood that there is something that is either nearly identical or very close to what you want to build. And so your first move out of the gate should always be to go find a quick start template that is similar to what you want to do. Or if there's a particular feature you're trying to figure out or a particular thing you're trying to achieve in an infrastructure capacity, searching the quick start templates is a good place to begin, because usually you can find something that's close that you can modify for your purposes, or you can, it's a lot easier to do this than try and figure it out with the documentation and, trial and error. So I highly recommend starting with a quick start template. The second pro tip is to cheat more. And specifically, and this is one of those things it's definitely cheating, but I will tell you that everybody I know who builds Azure infrastructure has done this at least a couple of times, is to go and build your infrastructure in the portal with the clicky buttons. And then once you have your resource group created, you go down to and you export your template out of Azure. And that will give you an ARM template that, while not necessarily usable, not necessarily perfect, will give you a pretty good idea of how you want to structure your Bicep templates. So both of these things will give you a good starting place and save you a ton of time, as opposed to trying to do everything, everything from scratch. Another thing you can do is you can decompile existing ARM templates using the Bicep CLI. So if you have an ARM file, you can do an Azure Bicep decompile, toss that in there, and it will give you a Bicep file. This is definitely a hit or miss proposition. I've used this a couple of times, and it's one of those things that it's, about 50% of the time it works 100% of the time. It's not perfect by any means, but it's worth a shot. And if you have an ARM template that you want to convert, it's worth running it through the decompile. It costs you nothing. It takes less than a minute, and you might luck out and get something, or alternatively, you'll get a bunch of errors. Usually, you get a bunch of compile errors that you have to fix, which, if you fix them, maybe that'll be easy. But if not, well, the nice thing is that the data points are all the same, so you can manually convert them, which is a little tedious, but not that hard. And the final pro tip is to build pipelines. So I build pipelines for all of my infrastructure. I don't run anything from my computer unless I'm just testing. But if you want to have anything for your actual production infrastructure, you want to run that from a pipeline. You get repeatability, you get logging, you get tracking. It's a good deal. And if you're in a corporate situation where you need to lock stuff down, you can lock everything down by using the service accounts or your CI/CD tool, and you can satisfy all of your compliance requirements. So definitely build pipelines. So any other questions before we move on to the next section?
So from a pipeline perspective, and let's say you put your Bicep file in a private Git repository. How are, like, okay, so link templates has obviously a bunch of security issues, right? Does Bicep have those security issues too?
What do you mean by link templates?
Master templates. You know how a template can link to a sub template? You can have, like, for your load test environment, have a master template that feeds parameters and builds the resources off of sub templates, right?
Oh, that sounds more like a modules thing.
Yes, it's similar to the modules in Bicep, but the permissions really are very difficult to work with, since it processes the master template on the it processes the master template outside of the security framework for the private Git repo, right?
I got you. I haven't never run into that personally, but with the Bicep templates, the modules, I haven't had any trouble with those.
Awesome.
So on my project, we have a bunch of or the project I worked on that used Bicep templates. You know, we had our, you know, we didn't necessarily have like a master template and then downstream templates, but we had our different modules, and there was no issue. Like, we didn't have any trouble with it.
Yeah, so I have a little experience with that. So are you talking about like when you, for the ARM templates, when you did the linked ones, you'd have to store the ARM template, right, in some sort of like public URL, like a.
Exactly. The link template has to be accessible publicly or from a URL, right? Because a template URL is a parameter.
Yeah, so the difference here with the Bicep modules is when you do that Bicep build, it actually just produces one big ARM template. So if you had a Bicep file that called like 5 modules, the output of that is a single ARM template. So there won't be any linked templates.
Okay.
So you don't have to put anything on a public URL.
So it does that Bicep transpile. It does that on the DevOps side before handing off. Okay, awesome.
Yep.
So it hands off one big ARM template to Azure. So.
And you can actually start with that. So I'm going to make that a little smaller. I got my zoom controls here. All righty. So let's get rid of that. Get rid of that. Okay. So we're going to start. This is kind of like the cloud cooking channel, where we're going to start with the cake that's already done, and then we're going to kind of like Tarantino it and show you how we built this infrastructure. Because I don't think you really want to sit around and watch pipelines run. So we're going to start with the end in mind. So let's pretend for a minute that we're building an application. That application is going to have an app services plan, app insights, SQL database, SQL server, and an app service. Pretty standard issue setup, right? So to create this resource group with this infrastructure, basically what we have is we start off with a pipeline. And that pipeline has 2 phases. So we have a build and a validate phase, and then we have our actual deployment phase. If we pop open our code here, we can actually start with that pipeline. So we'll go up to the top here. We have some variables, trigger equals none, running this on Windows latest. And so this build and validate has a couple of different jobs in here. So the first one we're going to do, actually, just has one job. All right. So the first thing we're going to do is we're going to validate our templates. And what's nice about this is just another linting process so you can catch issues. And the way we're going to do that is we're going to use TTK. So that's the Azure, you can use this for ARM templates as well. So this is basically a linting tool for Azure files. And so the first step is we're going to download that tool. Then we're going to download Bicep and install it using the AC Bicep install command. In theory, if you weren't using an Azure agent, you could install this before, but I don't know if it's actually on the Azure agents now, but it wasn't when we built these pipelines. So that's where we're at. The next thing we're going to do is we're going to build our Bicep templates, and we're going to compile them into ARM. So we're doing an AZ Bicep build, and then we're going to run our practice tests or our tests on them. And this will throw an error if we fail any of those tests, and that error is going to look like this. So if you come into our pipeline, this is an example of a linting error that blows up your pipeline. In this case, we have admin password that was being set that wasn't being set correctly. And there's a bunch of other different rules as well. And these update over time. This one was actually a new one that they added because when I was building up this this application for the talk, got burned by this one and had to fix it. So these rules update over time and get more restrictive. So that's a positive thing. It's nice to stick with best practices and all that. So once that's done, it copies the output. So including the bicep files, the parameters files, our parameter file, and our deploy files all up to the staging directory, and then those get published as artifacts. So in our next phase, what we're going to do is we deploy that out. We depend on our build and validate step, and we have our variables. This is for our dev environment. We have our parameters file, which is right here. There's no secrets in here. It's just static data. And then we are going to have our resource group, and then we're just going to run a script. So we're just going to run this deploy app script, which if you come here, doesn't do a whole lot. It's just a little PowerShell. And this is probably pretty familiar since I've had like 3 slides with this on it, where you just create your group and you do your deployment group create, passing in that environmental config and our bicep file. In that, we go to our bicep file, scroll up to the top, we have a variety of parameters. So these parameters here are to generate names because I don't want to have to put in names for everything. So we're just going to put in some basic variables and generate the names programmatically. And then we have our application, our app services plan tier, and then we have our database tier variables or parameters. And we have some variables where we use a string interpolation, create names for everything. And then we activate our first module. So the first module, we create an application insights instance. So if we pop over to here, this is the application insights module. We have a few parameters. To create a application insights, we have to create an analytics workspace. That's a relatively new requirement. Used to be able to just create application insights. Now you got to create a workspace, so whatever. So here we are creating our workspace. Something I've done is I kind of leave breadcrumbs sometimes in these where I actually link to the documentation, but if you don't want to do that, the key to getting to the actual API documentation is to search for this right here, like the actual Azure name of the resource as opposed to the like marketing name, and this will get you to the actual documentation as opposed to getting you to like the Azure marketing page. Bonus pro tip. So for our workspace, we're going to throw in our workspace properties. This is boilerplate code, but we want to make sure we put a cap on this because they charge by the gigabyte, and it's really easy to rack up costs by not limiting the amount of logging that you throw, or limiting the amount of telemetry you throw into application insights. So it's a fun way to end up with a nice surprise Azure bill. So here we have our application insights instance. So that's insights.components. We come in here with our name, location from our parameters. We have our analytics ID. We have our depends on. And then what we're going to do is we are going to output our instrumentation key and our connection string, because those are going to be things we're going to want to use in our application to hook up to application insights later on. So we have our app insights, that's ready to go. The next thing we're going to do is we're going to build a database, and that's another module. Modules, it's nice to break things down. Our database module is going to have a couple parameters, so our name and our tier. We're going to create an admin name, and then I don't really care about the admin password. I tend to use the Azure Active Directory type of permissions as opposed to having the admin password. So we're just going to make this a giant GUID and forget about it. So we're going to use the secure parameter here to make sure we don't output that anywhere and make that a secure string. And then we're just going to have a unique name for our admin name. It's, not SA. Next up is we're going to create our server. drop in our admin name and password, and then we're going to actually create our database. And so the server, one thing here is when you do this name, you have to make sure your server name is part of the name, or else it's going to throw an error. So that was something I found kind of unintuitive. Like in other Azure services, you tend to have, you just link to your kind of parent resource, like with your apps or with your app service plan, you link to it using an ID. But for some reason, you have to put in that specific name in order for it to work. Just something to look out for there. Drop in our depends link and our SKUs, and then go back up to here. So the next thing we're going to build is our application service plans. This is essentially our server that we're going to run our application, our web app on. Come in here, we have a location, drop in our SKU name and tier. We're going to do a Linux app services plan because it's going to be a .NET Core application. And then on to the service. This is going to be an Azure website. Again, name, location, depends on App Insights and the app service plan. And then we have our site config. There's a couple important things in here. This right here is super important. If you're running a Linux app services plan, you need to make sure this is set to whatever version of .NET Core you're using. So now that 6 is out, we'd want to update this to 6, or else you're going to get a fun time. This is one of those non-intuitive things that's not super well documented, but you do have to set that. And then you can throw in your app settings. So you have your instrumentation key and your connection string in your app settings. So you could also throw in like your database name and tier as well if you wanted to, or you can add those later. And that's pretty much it. So that is our, so that's pretty much what we have here in terms of infrastructure. Do we have any additional questions or comments?
You didn't create any temporary storage, right, for the pipeline? I thought there was a file. Were you doing a file copy in there or something?
Let's see. In the pipeline, I don't create any temporary storage in the pipeline, but basically when you do this, when you publish this to the output directory and publish the build artifacts, those artifacts are stored in Azure DevOps. So if we go back to this one, we can go here. You can actually download the artifacts if you want. So if you can come in here, you can see what actually is being output. And so just for fun, we can actually check and see what our, see what that looks like. Let's see what this actually opens in. I guess that'll work. And so this is actually what Bicep produces, this JSON file here. And so as you can see, it's very verbose and very long. It's not super long, but you're looking at 273 lines of JSON, which is kind of hard to read versus, let's see, 80, 120, 156, 160-ish lines. So even just from a straight up lines of code savings, you're actually saving a ton of just, there's just a lot less cruft using the Bicep templates, even with all these modules and files, because even if we got rid of the modules, it'd be less, be even fewer lines of code, but it wouldn't be as easy to parse. But yeah, Azure DevOps just stores it in Azure DevOps, and you can download it or use it in your later phases of your build. So you don't have to declare your own storage or anything. Any other questions? All right, everybody's very talkative today. All right, well, I guess we can continue. So if you want to find more information about Bicep, the probably the best place to start is the Azure Bicep page on GitHub. That actually has a link to, there's a like Bicep tutorial where you go through and you build infrastructure. It's a really nice thing. It also has all the documentation for Bicep, which is good. Obviously, hit up those quick start templates. Highly encourage you to start with something whenever you build these. It just makes your life a lot easier, whether it's a quick start template or whether it's resources that you pull out of like a manually created resource group. But either way, that's going to really shorten your time to figure this stuff out. And then finally, you have the ARM and Bicep reference. So it's important to note that Bicep and ARM are the same API. And what's nice is that in the actual documentation, they now have, both Azure, both Bicep and ARM documentation. So if you come in here, you have, even Bicep is first now, apparently. So maybe Microsoft is telling us something. But as you can see, it's the same data points, just in a more terse format. So I got a couple of takeaways. One, infrastructure as a code is a must for any kind of modern architecture. If you're not using infrastructure as code, you really should be. It's just super important for all the reasons I mentioned before. I like to use pipelines to build infrastructure. It's it makes your infrastructure more repeatable. It's nice to be able to check the progress, logging, that sort of thing. And finally, Bicep is like ARM, but better in pretty much every way. So if next time you want to build some Azure infrastructure and you're looking into using ARM, I would skip it and go straight to Bicep. It's a much friendlier format for building infrastructure. And that's all I got.